Mathematics is engaging. Students here are all amazing. Let's have a fun learning. Good afternoon, class. I am teacher J. Lord Dayday.
And I am teacher Johnny Luis Nogra.
And we are your math teachers for today.
So before anything else, let's stand up first for a prayer. So Miss Lau, can you please lead the prayer? In the name of the Father, the Son, and the Holy Spirit. Amen.
Okay, so before anything else, let us check the attendance first. Ambrad Hanalay, Alahid Riza, Dihito Jovine. Okay, very good. No one is absent for today. So with that, give yourselves 3 claps, class.
Okay, now since no one is absent, so today let's open up a new topic. But before that, let's have a game first. So this game is entitled Decode the Message. And the instructions will be given by teacher Dayday.
Okay, so these are the mechanics for our game today. So first, divide the class into 2 groups. Group 1 will be assigned set A and Group 2 will be assigned set B. Each group will work on solving the problems provided in their respective sets. Each group will find the answer from the given choices in their respective sets in order to decode the message. Each group will be given 5 minutes to finish the activity, and each group will select one representative to present their answer.
So now we'll divide the class into 2 groups. So count off. So 1, 2, 1. Okay, so all group 1 be seated here, and all group 2 be seated here.
Okay, so set A for group 1. So take a look at your problems and please copy that problem on one whole sheet of paper. Okay, done? Group 1? Okay, so let's proceed to the set B. So group 2, please take a look at your problems and write it down in one whole sheet of paper also. So again, you are given 5 minutes to complete the activity. Okay, 2 minutes left. Okay, time is up. So each representative from the group, please present your answer here in front. Okay, group 1. Okay, very good. So group 2. Okay, very good. So again, to find out if their answers are correct, so let's check. So in set A, what do you think is the correct answer? What's your answer again, group 1? It's remainder. Let's find out. Very good. It's remainder. And in set B, group 2, what's your answer? Factor. Okay, let's find out. It's factoring. So very good.
So in relation to that game we had just a while ago, so we have an answer of remainder for set A and factoring for set B. So in relation to that, at this moment, let's have an activity. So instructions will be given by teacher Dayday again.
So for this activity, you're going to pair up with the classmates. And each pair gets a pair of polynomial to solve and use the remainder theorem to find the remainder when dividing each polynomial by a linear division. The next, once you have the remainder, apply the number 5. So factor theorem to identify the corresponding factor. Then last, discuss your approach with your partner and help each other to understand the process. Okay, so we have here a card. So each pair will receive 1. Okay, so you are given 2 minutes to complete the activity. Okay, time is up. So we have here an essential questions. So first, what can you say about the results of the two separate solutions? Anyone? Don't answer me, chorus. Yes, Miss Arabis. Very good. So, the two separate solutions are related to each other. So, another one. Any idea? Yes, Miss Orbiso. Very good. So, the first solutions has a number which is considered a leftover amount or a leftover number. So, that is what we call remainder. Very good.
Another question is, what challenges did you face in finding the remainder and factor of a polynomial? Anyone? Yes, Mr. Susania? Okay, so you're having a hard time in internalizing an appropriate solution to come up with an answer. Well, to fix that problem, let us now elaborate our discussion for today. So starting first with the remainder theorem to be discussed by teacher Jalor Taytay.
So our topic for today is all about remainder and factor theorems. But before that, let us read our objectives for today's lesson. So at the end of the lesson, the students are expected to prove the remainder and factor theorems, compute the remainder using synthetic division or the remainder theorem, develop a positive attitude towards approaching and solving problems related to polynomial division, instilling confidence in handling challenging mathematical concepts, and recognize the importance of precision and accuracy in mathematical reasoning, cultivating a value for careful problem solving. So first, we have remainder theorem. So in solving the remainder, there are two methods. The first one is the remainder theorem, and the second one is the synthetic division. So here in remainder theorem, if a polynomial p of x is divided by x minus a, then the remainder is r equals p of a. So later on, as we go deeper with the discussion, let us discuss that further. The next in synthetic division, as you can see here in our example, you're going to construct a synthetic division table. So later on as well, let's discuss that further. So here, our example number 1, find the remainder when x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3. So again, we can find the remainder in two methods. The first one is correct, the remainder theorem, and the second one is the synthetic division method. So here, for this example, we're going to use first the remainder theorem. So in solving this, let's follow the steps. So the given polynomial is x cubed plus 2x squared minus 5x plus 2 divided by the linear x plus 3. So the first step in finding the remainder using the remainder theorem is to equate this linear to 0. So we have here x plus 3 is equal to 0. So therefore, x equals negative 3. So the next step here is to substitute the value of x. So we have our value of x here is negative 3. So let's substitute the value of x. So negative 3 x cubed plus 2 times negative 3x squared minus 5 times 3 plus 2. Just copy that to the constant number. And then we're going to simplify. So the result is positive 8. So therefore, the remainder is 8. So our remainder here using remainder theorem is 8. So at this time, let us use synthetic division with the same given polynomial. So let's see if the results are the same with the remainder theorem. So let's solve. So again, the given polynomial is x cubed plus 2x squared minus 5x plus 2 divided by the linear x plus 3. So using the synthetic division method, you're going first to create a synthetic division table. So it's look like that. So the next step that you're going to do is again to equate this to 0. So we have x plus 3 equals 0. So x is negative 3. X here is negative 3. So you are going to put negative 3 here. And then it is understood that there is a 1 here. And then 2, the coefficient, and then negative 5. So you are going to put all the coefficient here. 1, 2, negative 5, and then bring down the constant 2. And then bring down first the positive 1. And then the next step is multiply negative 3 and positive 1. So the result is negative 3. So you are going to put negative 3 here. And then afterwards, you have to apply the addition. So 2 plus negative 3 is negative 1. And then multiplication again. So negative 3 times negative 1 is positive 3. So addition again. So negative 5 plus 3 is negative 2. So you're going to apply the multiplication again. Negative 3 plus negative 2 is positive 6. Then addition 2 plus 2 plus 6 is 8. So this number here, the last number, is our remainder. So going back to the remainder theorem, using the remainder theorem, our remainder is 8. And then using the synthetic division is 8 also. So we can say that you can use either from the two methods in order to find the remainder of a given polynomial. So we have here next example. Okay, so kindly read, everyone. So divide the polynomial function f of x equals x cubed minus 2x squared plus x minus 3 by x minus 2 using remainder theorem. So first, we're going to use the remainder theorem. So we're going to write here the given polynomial x cubed minus 2x squared plus x minus 3 divided by x minus 2. So again, what is the first step in solving remainder theorem? Yes, Miss Wagas. Very good. So we're going to equate this to 0. So x minus 2 equals 0. So our x here is positive 2. Our x here is positive 2. And then the next step, what is the next step? Yes, Mr. Dihito. That's correct. So we're going to substitute the value of x to the given polynomial. So 2 cubed minus 2 times 2 squared plus 2 minus 3. So we're going to simplify. So the result is negative 1. So the remainder with this given polynomial is negative 1. So using remainder theorem. So now let us use again the synthetic division using the same polynomial. So we're going to use the synthetic division. So again, what is the first step? Yes, Miss Alahe. That's correct. So first we are going to create a synthetic division table. And then the next step is, very good. So equate this one to 0. So x minus 2 is equal to positive 2. The next, we're going to put negative 2 here. And then get the coefficient in the given polynomial. So we have 1, negative 2, 1, and the constant negative 3. And the next, bring down the first number, which is 1. And then multiply, apply the multiplication. 2 times 1 is positive 2. And then add, so this is 0. Since negative 2 plus 2 plus positive 2 is 0. Then next is multiply again. 2 times 0 is 0. So add 1 plus 0 is 1. Then multiply 2 times 1 is 2. So add negative 3 plus 2 is negative 1. So the last number here is our remainder. So going back in the using remainder theorem, the result is negative 1, and using synthetic division, the result is negative 1 also. So the results are the same. So again, you can use either from the two methods, using remainder theorem or the synthetic division, because the results are still the same. So at this time, I want you to solve that given polynomial using remainder theorem and synthetic division method. 2 minutes. Okay, time is up. So I want 2 representatives from the class to please come in front. One student to solve the remainder using remainder theorem, and one also for the synthetic division method. So anyone? Yes? Is here using synthetic division. Synthetic division. And here is using remainder theorem. Using remainder theorem. Okay. So now. Okay, time is up. So now let's see their work. So let's solve first using synthetic division. Let's find out if their answers are correct. So first, here the synthetic division method. So the given polynomial is x cubed plus 2x squared plus x plus 1 divided by x minus 1. So again, the first step in synthetic division is to construct a synthetic division table, and then the next one is equate this to 0. So x minus 1 equals 0. So therefore x is equal to positive 1. So our x here is positive 1. So put positive 1 here and then get the coefficient each of the terms. So we have here x cubed, so 1, 2x cubed is 2, x is 1, then you have the constant 1 also. Then the next step is bring down positive 1 here. So 1 times 1 is 1, of course. Then, so apply the addition to plus 1 is 3, and multiply again. 1 times 3 is 3, and then add again. So 1 plus 3 is 4. Multiply. 1 times 4 is 4. And then add 1 plus 4 is 5. So therefore, using synthetic division, for this given polynomial, our remainder is 5. So, and now let's see if the answers are correct. The remainder are the same using remainder theorem. So, using the same polynomial, so the given linear is x minus 1. Equate this to 0, so x equals positive 1. And then substitute, so 1 x cubed plus 2, 1 squared plus 1 plus 1. So we're going to simplify, so the result is 5. So therefore, with using the two methods, so the results are the same. The remainder is 5. So their answers are correct. So, any questions before we proceed? Anyone? None so far? Okay. So, since we're done with remainder theorem, and I think that you really understood our topic for today, I mean the topic about remainder theorem. So, at this juncture, I am going to introduce to you Teacher Nogra to discuss about factor theorem.
Okay, thank you, Teacher Dai. So much for the remainder theorem. Now let's proceed to the factor theorem. So factor theorem defines that if P of A is equal to 0, then x minus a is a factor of P of x. Conversely, if x minus a is a factor of P of x, then P of a is equal to 0. So we have here an example. So example number 1. So this example is already based on a given example by Teacher Dai just a while ago. So we have a function of x is equal to x cubed minus 2x squared plus x minus 3 divided by x minus 2. And we also know that the remainder is negative 1. Therefore, we can say that the divisor x minus 2 is not a factor of the given polynomial or the given function. However, if the remainder is equal to 0, then we can say that it is a factor of the given polynomial, just like we have in the example number 2. But let's check first if the remainder is really 0 to this polynomial, like 2x cubed minus 5x squared minus x minus 6 divided by x minus 3. So in the solution for this factor theorem, we're just going to apply the remainder theorem. So to find this remainder, we're just going to use either of the two methods. So again, what are those two methods? Yes, it is the remainder theorem and through synthetic division. So now let's just use the remainder theorem. So let's find it out. So we have a polynomial of 2x cubed minus 5x squared minus x minus 6 divided by x minus 3. So again, if you're really listening to Teacher Dai a while ago, what is our first step in finding for this method, in finding the remainder of this method? Yes, correct. It is through equating the divisor, so this one into 0. So let's equate this to 0. So our value of x is equal to, yes, it is 3. Positive 3. So now we already have the value of x. What are we going to do next? Yes, it is to substitute our x to the given polynomial. So let's substitute this one. So, you have 3 cubed minus 5, 3 squared, minus 3 minus 6. Next is we're going to simplify this one. So what is 3 cubed? It's 27. How about 3 squared? Yes, it is 45 minus 3 minus 6. And if we're going to simplify this one, we get a polynomial p of x is equal to 0. Yes, 0. So now, since our answer is 0, therefore, it is true that the remainder is 0. Therefore, since the remainder is 0, we can say that the divisor x minus 3 is a factor of the given polynomial. So again, class, take note that through remainder theorem, we can lead to the factor theorem. Am I understood, class? Okay, well, that's good to hear.
Okay, since we're done with our discussion for today about remainder theorem and factor theorem, at this time, I want to test you if you really understood our topic for today. So what is remainder theorem all about? Anyone? Yes, Miss Gulfan. Very good. So, remainder theorem, think of a polynomial division as a form of sharing. So, when dividing a polynomial by a linear factor, the remainder theorem reveals what is left, just like the remainder when sharing objects among friends. Thank you so much, Ms. Gulfan. How about factor theorem? Anyone? Yes, Ms. Orbeso again? Very good. So, now consider the factor theorems as the detective work of polynomials. So, when we identify a root or a solution to a polynomial equation, the factor theorem helps us uncover the associated factors. So, thank you so much, Ms. Orbeso. So I think that you really understood our entire topic for today. So at this time, let us have an activity. So get one whole sheet of paper, class, and copy your activity. So for set A, provide at least one polynomial problem and solve it using syntactic division. So of course, you are going to set up the syntactic division table. And for set B, solve this problem correctly. So, the volume of a rectangular solid is x cubed plus 3x squared plus 2x cubic centimeter. And its height is x plus 1 centimeter. So, what is the area of the base? So, you are given 10 minutes for this activity. And afterwards, please pass your paper in front. Okay, start now. 2 minutes left. Okay, time is up. Pass your paper in front. 1, 2, 3. Okay, thank you so much. So at this time, I am going to introduce to you teacher Nogra again to facilitate the assessment.
So now, since you thoroughly understand our lesson for today, are you now all ready to face a more challenging activity? Ooh, that's the spirit. Well, you should be. So now, I want you to get a one whole sheet of paper and answer this one. So this is a 15-item test, and you are also given 15 minutes to answer this one. So 2 minutes left. Okay, time is up. So pass your papers in front in 1, 2, 3, 4, 5. So, thank you. Are all papers in? So, okay. So before we will end our discussion for today, be reminded that I want you to perform this task at home or if you have any free time. So answer this one in a one whole sheet of paper and this should be passed next meeting. Am I understood, class? Okay, that's good to hear.